Okay friends, now I am going to explain the topic limits. So this is a very easy topic in the IP for TS and AP. So in this topic we should first of all learn what are the limits and how to find out the limits. So here I will take the one function here, that is f of x is equal to x power 2 minus 4 by x minus 2. So this is the function f of x is equal to x square minus 4 by x minus 2. So here what is the value of f of x at x is equal to, what happening here, when f of 2 is equal to 4, 2 square means 4 minus 4 by 2 minus 2 is equal to 0 by 0. It is the undefined. It is the undefined undetermined form. So this is the answer, but we are again here again we want to find out this answer approximately. So for that purpose I will take a small box here, that is this table contain, this is the value of x, this is the value of the f of x. So then now I will take that the value of x when 2, the value is what, 0 by 0, it is the undefined. So we have to find out the nearby values to the f of x, that is example from here you should take that x square minus 4 by x minus 2 is equal to x plus 2 into x minus 2 by the formula of a square minus b square is equal to a plus b into a minus b by x minus 2. That will be cancelled here. How much here? X plus 2. So now the value of f of x is how much here? X plus 2. Now take that the value of x, if you take the 1.99, 1.98, 1.97, here 2.01, 2.02. Then what are the values of the f of x? Here x plus 2 means here 3.97, 3.98, 3.99, here 4.01, 4.02. These are the values here. So now here the x is approaching to the 2 from this side. So then when x is tending to 2, then f of x become what here? 0 by 0. So when x is tending from this side to the 2, then f of x become what here? 0 by 0. Means here when the x is tending to 2, so here the x is tending means it is the reaching the 2 but not become the 2. So then the f of x is reaching to the some value. So this is called the limit extending. We can write this one as the limit extending to 2. That means when the x is tending to the value of f of x, So here, so when x is tending to 2, and here what is the value become here? Become the 4. If you take this from here, become the 4. And it means when the x is tending to 2, then f of x is tending to the 4. So therefore limit extending to 2, f of x is equal to become how much? This is the 4. That means when the x is reaching to the 2 but not becoming 2, so then the f of x become the 4, nearly 4, like this 3.99 or 4.01. So in this case, when the x is approaching from the left side, this is called as the left side limit. We can write it as what here? Limit extending to 2 minus, because it is approaching from the left side. So when the limit is extending from the right side, this is called as the right hand limit. We can write as the limit extending to 2 plus. Means for at the x is equal to, there exists the left side limit and right side limit. Then limit extending to f of x, then f of x, both are exist. So when limit extending to 2 minus f of x is equal to limit extending to 2 minus f of x. When both are equal, means from the left side and right side they are reaching the only same value, then the limit will be exist the point 2. Otherwise the limit does not exist. So where the limit does not exist, you have to observe here. Example, we have one graph like this. The 1, it is the 2. It means here when the x is less than 0, the value of function how much here? 1. When the x value is greater than 1, what is the value here? 2. Means here limit extending to is tending to 0. Yes or no? Therefore 0 minus means it is the left hand limit. Then f of x is equal to how much? We have 1. When limit extending to 0 positive means right hand limit like this, and the extending from the right to 0, then f of x is equal to how much we got here? 2. Means in this case the left hand limit and the right hand limit both are not equal. In this case the limit does not exist, and in this case the function is discontinuous, means we cannot draw this function without lifting pen. So when if you can write a function, if you draw a function, a graph of function without lifting the pen, that is called as the continuous function. So here you have the break here. That's why in this region means if the x is equal to 0, the function does not continuous and there is no limits. Now we should know how to write the left and right limits. So here we'll take the small function that is f of x. So the graph is like this. This is the function f of x. This is the x-axis. Sorry, x-axis. This is the origin. This is the y-axis. So I will take the value of f of x to the point in the a. Taking the a. So here the value of f of x at the a is like this. This is the value of the f of x at the x is equal to a. So now take a small number, that is the h, which is greater than 0, but it is the near to 0. Is near to 0. So if you take the minus h, the value will be here like this. Take the plus h, it will be like this here. So what happens here? It becomes the a plus h from the a minus h. So it is the a plus h, it is the a minus h. So now limit h is becoming 0 ante x is small value, the x is 10 to 0, x is a small value, then f of x is what here? F of a minus h from the left hand limit, then limit extending to 0 plus, then f of a plus h. So when the h is becoming 0, then the value become f of a only. So when h becomes 0 here, the value becomes f of a only. So this is called the left hand limit, this is called the right hand limit. So in this case, when the x is tending from the left side to the a or right side to the a, the both will get the f of a only. That's why in this case the left and right hand limits will be exist, and therefore if the x is equal to a, the limits are possible. Those are these limits, left hand limits and right hand limits. So in this way we can write as the left hand limits and right hand limits. So friends, now I am going to explain sandwich theorem. So what is sandwich theorem? First of all, here I am taking the three functions, that is f of x, g of x and h of x. So these three functions will form from E to R, E set to R set, and f of x is not is equal to g of x is not is equal to h of x and for all x belongs to E. So in this case, so limit extending to a f of x is equal to limit extending to a h of x is equal to L. So simply here, so limit f of x and limit h of x both are become the L. So when f of x and g of x become L, that means limit extending to a f of x and limit extending to a h of x both are become L, then limit extending to a g of x also become L. This is the sandwich theorem. Simply, if you want to know here, if a less than or is equal to b less than or is equal to c, and then a is equal to c is equal to 1, then automatically b also become 1. So based on this theorem, the sandwich theorem is implemented. So when what happen here, f of x less than or is equal to g of x less than or is equal to h of x. So when x belongs to E, so then limit extending to a f of x is equal to limit extending to h of x is equal to L. That means the f of x and g of x, these limits are become the L. Then automatically the limit extending to a g of x also become L. This is the sandwich theorem. Okay, based on sandwich theorem, we have to find its answer. It is compute limit extending to 0 x square sine 1 by x. So we know that here the range of sine is -1 to +1. It means for the any value of x, the sine value lies between the -1 to +1 only. Therefore, sine x is equal to -1, is equal to 1. So here now, so sin x between -1 and 1. Same way, sine of 1 by x also lies between the 1 and -1, because for any value of the x or 1 by x, the sine give the values from the -1 to 1 only. If you observe the graph of the sine like this, for any value of x, the value is between the -1 and 1 only. Therefore, it is the range -1 to 1 only. That's why -1 less than or is equal to sine 1 by x less than or is equal to x. Now multiply x square to all the terms. Therefore, -1 into x square less than or is equal to x square into sine 1 by x less than or is equal to 1 into x square. Then become minus x square less than or is equal to x square sine 1 by x less than or is equal to x square. So now apply the limit for all the terms. So apply limit extending to 0 to all the terms. Become that limit extending to 0 minus x square and less than or is equal to limit extending to 0 x square sine 1 by x less than or is equal to limit extending to 0 x square. So observe here, so x square is a polynomial. X square is a polynomial. If you can write the right x value here, become what here, become that, so minus 0 whole square less than or is equal to limit extending to 0 x square sine 1 by x less than or is equal to 0 square. Become the 0 less than or is equal to limit extending to 0 x square sine 1 by x is equal to 0. So when the limit extending to 0 x square sine 1 by x lies between the 0 and 0, means Therefore, the limit extending to 0 x square sin 1 by x is equal to 0 by the Sandwich theorem. When f of x, g of x, h of x, when f of x and h of x both become 0, then automatically the g of x also become the 0. Therefore, limit extending to 0 x square sin 1 by x is equal to 0. This way you can find out the value of limit extending to 0 x square sin x. So friends, next example, compute limit extending to a x square minus a square by x minus a. So if you substitute x value in place of a value in place of x, then become what? Become a square minus a square by a minus a. Nothing but 0 by 0. It is the undefined. Therefore, you should not get this number. You should not get the 0 by 0 or something by 0, like this. So for that we have to change something here. Take that limit extending to a x square minus a square by x minus a. So here limit extending to a, write the x square minus a square is the x plus a into x minus a by x minus a. I have applied here formula a square minus b square is equal to a plus b into a minus b. Now x minus a get cancelled, then we get limit extending to a x plus a. Now after the limits here means we have to write the a in place of x. It become a plus a is equal, that becomes what, to a. So this is the answer. So when you are doing the answers, you should not get the values like this 0 by 0 or something by 0. They are the undefined forms. That's why you should not get these values. Next question says f of x is equal to x by 2 if x less than 2, x square by 3 if x greater than or equal to 2. So then find the left and right hand limits at a is equal to, and check at the a is equal to 2 limits are exist or not. So this problem we can solve very easily. First of all, we should find out the left hand limit. But here limit extending to 2 minus f of x, because we have found out the limit at a is equal to, that's why taken the x tending to 2 minus f of x. So here x is tending to 2 minus means it's less than 2, so we take this one. So therefore limit extending to 2 minus, when x is less than 2, the function is what here, x by 2. Therefore now apply the limit here. So write the value of x. Therefore 2 by 2 become the 1. Now take the right hand limit. It is what here, limit extending to 2 plus or 2 positive f of x, means in this case the limit is 2 plus more than 2, means x greater than or equal to this case. That's why take the f of x is x square by 3. Therefore limit extending to 2 plus square by 2. Now apply the limit, means write the 2 in place of x. Therefore 2 square by 2, so this is 3. 2 square by 3 is equal to from the 4 by 3. Therefore left hand limit not is equal to the right hand limit. Therefore it is the LHL, left hand limit. This is the right hand limit. Therefore both are not equal. Therefore, so when both are equal only, then let x at a is equal to, the limits will exist. But here they are not equal. That's why therefore at a is equal to 2 or x is equal to limits does not exist. This way you will check the limits exist or not. Next question says f of x is equal to x by 2 if x less than 2, x square by 3 if x greater than or equal to 2. So then find the left and right hand limits at a is equal to and check at the a is equal to limits are exist or not. So this problem we can solve very easily. First of all, we should find out the left and limit, but here limit extending to 2 minus f of x, because we have found out the limit at a is equal to, that's why taken the x tending to 2 minus f of x. So here x is tending to 2 minus means it's less than 2, so we take this one. So therefore limit extending to 2 minus, when x is less than 2, the function is what here, x by 2. Therefore now apply the limit here, so write the value of x, therefore 2 by 2 become the 1. Now take the right hand limit, it is what here, limit extending to 2 plus or 2 positive f of x, means in this case the limit is 2 plus more than 2, means x greater than or equal to this case, that's why take the f of x is x square by 3, therefore limit extending to 2 plus square by 2. Now apply the limit, means write the 2 in place of x, therefore 2 square by 2, so this is 3, 2 square by 3 is equal to from the 4 by 3. Therefore left hand limit not is equal to the right hand limit, therefore it is the LHL, left hand limit, this is the right hand limit, therefore both are not equal. Therefore so when both are equal only, then at x at a is equal to the limits will exist, but here they are not equal, that's why therefore at a is equal to 2 or x is equal to limits does not exist. This way you have to check the limits exist or not. So now you have to see some important formulae. So they are limit extending to a x power n minus a power n by x minus a is equal to n into a power minus 1. This is the formula, so you can use in the problems. Next, limit extending to 0, 1 plus x whole power 1 by x is equal to e. So next limit extending to 0, a power x minus 1 by x is equal to log a base e. Next, limit extending to 0, e power x minus 1 by x is equal to 1. Same way, limit extending to 0, log of 1 plus x by x is equal to. So in the same way, go for the number from here, it is limit extending to 0, sin x by x is equal to 1. Limit extending to 0, cos x is equal to 1. And limit extending to 0, extending to a, p of x is equal to p of a. So we can apply this formula when p of x is a polynomial. So these are the formulae we can use mainly in the exercise. So now I am going to explain some very important questions for the IPA exams. So let us see. Next problem, compute limit extending to 0 a power x minus 1 by b power x minus 1. So first of all, you can find answer very easily. See here, limit extending to 0 a power x minus 1 by b power x minus 1. If you observe here, you have the formula limit extending to 0 a power x minus 1 by x is equal to log a bc. Means we have to need the 1 ax minus 1 by x and b power x minus 1 by x. Therefore, divide the numerator and denominator with the x. Therefore, divide numerator and denominator with x. Therefore, limit extending to 0 a power x minus 1 by x by b power x minus 1 by x. If you cancel the x, we get again this form only. So if you multiply and divide for the both numerator and denominator, there is no change of value. That's why we have to do the division for the both a power x minus 1 and b power x minus 1 with the x. Now apply the limits for the both terms here like this. Limit extending to 0 a power x minus 1 by x by limit extending to 0 b power x minus 1 by x. So what is the value of a power x minus 1 by x? A power x minus 1 by x. If you have the a here, you get the a. If you have the b here, you get the b simply. That will become what here? Become that log a bc by log b bc, because in the place of a we have the b only and the remaining same stays. Therefore, log abc log bbc, this is the answer. Therefore, write like this. Therefore, limit extending to 0 ax minus 1 by b minus 1 is equal to log a bc by log b ac. Next, see the second problem, that is what here? Find the value of limit extending to 0 sin ax by sin bx. It is one of the important question. So now that limit extending to 0 sin ax by sin bx. So if you observe here, we have the formula what? Limit extending to 0 sin x by x is equal to 1. So see here, sin x, so what is the angle here? We have the same thing here. Sin x by x, sin a by a, or sin ax by ax, sin bx by bx. Then only we get the 1. So here we have the sin ax, but we have what here? Here we need sin ax by ax and sin bx by bx. Simply multiply sin ax, multiply with ax and divide with the ax for the numerator by here sin bx, multiply with bx and divide with the bx. I will like that. Limit extending to 0 sin ax by ax by sin bx by bx. Now write that here we have the ax here, bx. X is a big cancel here. So now take the ab outside. Therefore, a by b into limit extending to 0 sin ax by ax by, apply the limit for this also. Therefore, limit extending to 0 sin bx by bx. See, we have to change the limits as well, because we get the sin limit extending to 0 sin x by x. We have the same values from here and here, x, then only we can apply this formula. But we have here x is here, we have the ax is there. See here now, when x is becoming 0, then ax also becomes 0 and bx also becomes 0. Now apply the limits like this. Now a by b into limit ax tending to 0 sin ax by limit bx tending to 0 sin bx by bx. I think it is not visible. I'll write hand upside. See here is equal to a by b into limit ax tending to 0, because when x tending to 0, then ax also tending to 0, into sin ax by limit extending to 0 sin bx by bx. Now further here, limit extending to 0 sin x by x is equal to 1. Same way, limit ax tending to 0 sin ax by ax, and limit extending to bx tending to 0 sin bx by bx to become 1. So now these two values are, this is the 1 and this is also 1. Now what here we have, now become that a by b into 1 by 1, nothing but a by b. Therefore we have limit extending to 0 sin ax by sin bx is equal to a by b. This way you can convert the answers. Okay, next these three also bad questions up to marks. So here we have limit extending to pi by 2, limit extending to pi by 2 cos x by x minus pi by 2. See actually here, so if you want to get the formula sin or cos, you should get that extending to 0 only. Sir, no. So when you have the extending to 0 only, you find out the value of the sin or cos. That's why you have to take that when x is tending to pi by 2, means when x becoming pi by 2, then x minus pi by 2 become 0, or x minus pi by 2 tending to 0. Simply send the pi by 2 this side, become x minus pi by 2. Now write here limit x minus pi by 2 tending 0 cos x by x minus pi by 2. Now take that, let x minus pi by 2 is equal to y. X minus pi by 2 is equal to y. Then what is x become? Then x is equal to y plus pi by 2, or pi by 2 plus y. Now write these two terms in the answer. And then get that limit x minus pi by 2 is y. Therefore y tending to 0. Now cos of x means pi plus pi by 2, or pi by 2 plus y by x minus pi by 2 is y. Now limit y tending to 0, cos pi by 2 plus y is nothing but sin y. Therefore sin y by y. See now sin extending to 0 sin x by x form, therefore it become 1. The value of sin x by x limit extending to 0 is 1, therefore become much 1, therefore 1. Like that, therefore limit extending to pi by 2 to cos by x minus pi by 2 is equal to 1. Now we go for the problem. Start here. Limit extending to 0 sin x minus 1 by extending to 1. Should we have the 1 only? Extending to 1 sin x minus 1 by x square minus 1. So different solution like this. So limit extending to 1 sin of x minus 1 by x square minus 1. So you can write the 1 as 1 square because 1 square always 1 only. Therefore now we apply formula here, a square minus b square. A square minus b square means a plus b into a minus b. Therefore it is limit extending to 1 sin of x minus 1 by x plus 1 into x minus 1. See here, we need that sin of x by x only we need, but what you have sin x minus 1 is here. So then we have to change the limit here. How we can change here? So when extending to 1, then x minus 1 tending to 0. Simply take the 1 this side, become minus 1. Therefore x minus 1 tending to 0. Now limit that x minus 1 tending to 0 sin of x minus 1 by, take this x minus 1 into 1 by x plus 1. Now apply limit for the both terms here. So limit extending minus 1 tending to 0 sin of x minus 1 by x minus 1 into, so write the limit as it is only. Limit x minus 1 tending to 0 means x tending to 1 only, therefore x tending to 1 by x plus 1. So sin limit extending to 0 sin x by x form, therefore this value become 1 by the our formula. What we come now is equal to 1 into 1 by, apply limit here means write the 1 in place of x, therefore 1 plus 1 become 1 into 1 by 2, therefore become by 2. Therefore that limit extending to 1 sin x minus 1 by the square minus 1 is equal to 1. Let's write the conclusion. Next, the last one here, limit extending to 0 sin ax by x cos x. So correct that limit extending to 0 can be as sin ax by x into 1 by cos x. Okay, now apply limits for the both terms here. Limit extending to 0 sin ax by x into limit extending to 0 1 by cos x. See here we need that sin ax by ax, so that's why we here multiply and divide with the a. Therefore limit extending to 0 sin ax by ax into a into limit extending to 0 1 by cos x. So here we have the sin ax by ax, so therefore we have the ax here. That's why when x becoming 0, then ax also becomes 0. Otherwise when x tends to 0, then ax also tends to 0. That's why limit ax tends to 0 sin ax by x into a into limit extend to 0 1 by cos x. So simply the value of this one become how much? 1. This also become 1 because limit extending to 0 cos x is always 1. Therefore what we have here, we got that 1 into a into 1 become a. That is limit extending to 0 sin ax by x cos x is equal to a. So in this way we can find out the answers. Okay friends, next limit extending to 0 sin of a plus bx minus sin of a minus bx by x. This is the one of the important question. It came number of times in examination. So here limit extending to 0 sin of a plus bx minus sin of a minus bx by x we have here. So now if you observe this one, sin a minus sin b form. So sin a minus sin b is equal to 2 into cos a plus b by 2 into sin of a minus b by 2. This is the formula. So now apply this formula it here. Therefore limit extending to 0 sin this is a minus sin this is b. Therefore 2 into cos a means what here, a plus bx plus a minus bx by 2, 2 cos a plus b by 2, then into sin a minus b. A means what we have here, a plus bx minus a minus bx by 2 by x become h. Now see here, limit extending to 0 2 into cos of bx get cancelled, 2a by 2 into sin of a plus bx, take minus inside, minus into plus minus a minus into minus plus bx by 2. So now a get cancelled here, now it cancel here, by x will be what it is. Now limit extending to 0 to cos a into sin bx plus bx become 2bx by 2 by x. 2 to get cancelled here. Next limit extending to 0 2 into cos a into sin of bx by x by x. If you observe here, 2 is a constant, so take outside, and then cos a also a constant because a is a constant here, that's why the cos a become the constant only. So if you have the x, it is a function, but we don't have the x, we have the a in the cos, that's why it's also a constant, take outside, become 2 cos a limit extending to 0 sin bx by x. See here we have the sin x by x formula, but we have here the sin bx we have here, therefore convert it also into the bx, therefore become 2 cos a limit extending to 0 sin bx by x. multiply with b and divide with the b. So now 2 into cos a, limit extending to 0, then bx also becomes 0. That's why that is bx tends to 0, sin bx by bx into b. So this value become 1 because limit extending to 0, sin x by x form become, how will write that, 2 into cos a into b. 2b cos a is the answer. This is the one of the bad question. It came many times in the examinations. So the remaining problems and topic will be see in the next video. Thank you.